Welcome to ClickMyProject.com.
Now we are going to discuss about the product Refinement De-haze-Net, a weekly supervised refinement framework for single image dehazing. Now we are going to discuss about the abstract of the process. One of the most interesting problems in recent times in image processing and computer vision is fog, haze and rainfall removal for images. In this paper we consider the problem of haze removal. Here the latest haze removal algorithm proposed based on the dark channel prior approach for haze removal. We proposes a process which is called the De-haze-Net. That means we have to remove the hazy pixels in the image for medium transmission estimation with DCP. Hence the De-haze-Net take a hazy image as an input and then the output is medium transmission map that is the subsequently used to recover a haze-free image via atmospheric scattering model. De-haze-Net based deep architecture layers are especially designed to extract the features of the hazy pixels which can generate almost all hazy relevant features. We also proposed a nonlinear activation function in De-haze-Net called bilateral rectified linear unit which is able to improve the quality of the recovered hazy-free image. Hence the main purpose of this process is to remove the hazy pixels and then retain the original pixels with an high quality. The performance of the parameters will be estimated based on the PSNR and MSE. By these two criteria we can estimate our process is efficient or not. Now we are going to discuss about the flow diagram of the process. This is the overall workflow of the process. At first stage of the process is the input image. The input image is taken from the dataset. The dataset carried out several hazy image. Then after getting the image from the input, we just move on to the next step of the process, that is the pre-processing. In this pre-processing we have two kinds of pre-processor, that is the image resize and data type conversion. In this image resize, the image is resized into an aspect ratio. That means the number of row and number of column will be resized into an aspect sizes. After resizing the image, we just convert the data type of the image. That means, for example, the image having the data type such as uint8, that is the unsigned integer, then the double, then long, like that the image data types will be there. As per our suitable image, we can convert the data type as unsigned integer 8. After the data type conversion, we just move on to the next step of the process, that is the haze detection and haze removal. These two steps are incorporated together based on the three kinds of step, that is the DCP, transmission and contrast enhancement. Based on the collaborative of these three steps, we just doing the haze detection and haze removal. First of all, I will explain what is the haze detection. Haze detection in this sense, we have to detect the pixels which consist of the hazy regions. After that, the haze removal consists of the steps to remove the hazy pixels and then retain the original pixels with the higher quality. After that, the output of the haze removal will be the de-haze image. In this de-haze image, only the pixels which having the aspect values will be there. Then the other unwanted pixels, that is the hazy pixels, will be removed from that particular image. After the haze removal, we just move on to the next step, that is the final step of the project, that is the pre-performance. In this performance, we have two kinds of performance parameters, that is the PSNR and MSE. PSNR stands for peak signal to noise ratio and MSE stands for mean square error. Now we are going to discuss about the initial running procedure of the process. At first, open the Matlab 2015B and change the current directory. If you want to execute the process, just right click in the main_GUI.yum and select the option run. Now the initial GUI was open. In that GUI you can see the several push buttons in the right side for the controlling actions and then the several axes in the left side for the display purpose. At first click the button input image. Once the button was clicked, you have to open the folder dataset and then you have to select any one image from the dataset. After the selection of the image from the dataset, the corresponding image is shown in the axis 1 with the title input image. After the selection of the input, we just move on to the next step of the project, that is the pre-processing. In this pre-processing, we have just done the image resize. The image is resized into an aspect ratio of 256 cross 256. That means the number of row will be the 256, the number of column will be the 256. The resized image is shown in the axis 2 with the title resized image. After done the pre-processing, we just move on to the next step of the project, that is the haze detection. Once the haze detection was clicked, it will take some time to execute the haze detection part. In this haze detection part, the pixel consists of the hazy pixels which will be detected like this. This is the image which represents the dark channel prior image. This is the image that is the medium transmission image. It will indicate the hue, saturations values, then the pixel intensities, then the differentiation of the pixels of hazy pixels that will be calculated, then the haze removal will be carried out. In this haze removal part, the hazy pixels will be removed. You can see the difference between the input and then the output image. The haze pixels will be removed and then the exact quality of the image will be regained. After the haze removal, we just move on to the performance estimations. In this performance estimation, we have two kinds. We already discussed. We have two kinds of performance, that is the PSNR and the MSE. In this PSNR, the value of PSNR is around 59.9 and then the MSE value is, that is the error rate. It will be the low only, so it will be the 0.06 something.